Some scientists, particularly those involved in biological sciences, will talk about something called a positive control. Other scientists might talk about something called a reference or a standard, and they're a similar type of concept. Biological scientists will also talk about something called a negative control. Now, both of these terms don't make a lot of sense until you understand what they mean, and then they're quite easy. Let's start by looking at a non-scientific example of a positive control. Have you ever bought a new car? Did you take it for a test drive first to get an idea of how it performs? Well, the test drive tells you the standard you can expect. When you get your new car, it might not be the actual car that you took on the test drive, but it should be the same model and it should perform similarly. Now suppose you take delivery of your new car, but it doesn't match up to the one you took on the test drive. Maybe it doesn't accelerate as well, or maybe some accessories are missing. You could reasonably go back to the showroom, point out the deficiencies, and ask for the new car to be either repaired, replaced, or maybe even ask for your money back. The test drive was your positive control. It set the standard. It showed you what should happen if things went well. If you hadn't taken the test drive, you might not have realized that your new car was defective. And that's why positive controls are so useful. They tell you what to expect if things go well. Let's now look at negative controls. A negative control is the opposite of a positive control. It tells you what should happen if your experimental intervention does nothing. I'll explain what I mean by that with an example. Suppose you've heard that adding grated beetroot to a chocolate cake mix makes the cake taste even better. So you head to the kitchen and you bake a chocolate cake with beetroot in it, and it tastes great. But wait, how do you know it's any better than your normal chocolate cake? The only way to test this is to bake a chocolate cake using your normal recipe, and instead of adding beetroot to it, you just use the regular ingredients. This is your negative control. It sets a standard if you do nothing to alter the recipe. So you can now compare the beetroot enhanced cake with the normal one and see if there really is a difference. Let's now look at some more scientific examples. For scientists, positive controls are really helpful because it allows us to be sure that our experimental setup is working properly. For example, suppose we want to test how well a new drug works, and we've designed a laboratory test to do this. We test the drug and it works, but has it worked as well as it really should? The only way to be sure is to compare it to another drug, and that's our positive control, which we know works well. The positive control drug is also useful because it tells us our experimental equipment is working properly. If the new drug doesn't work, but the positive control one does, we can rule out problems with the equipment because we know the positive control drug works. The negative control sets what we might call the baseline. I'll explain what I mean by that with an example. Supposing we're testing a new drug that's going to kill bacteria. It's an antibiotic. And to do this, we're going to count the number of bacteria that are left alive in a test tube after we add the drug. We could set up an experiment with 3 tubes. One tube would contain the drug we want to test. The second tube would contain our positive control. In other words, a different drug, but we know that works and it's going to kill the bacteria. And then the last tube, the third tube, is going to be our negative control. It's going to contain a drug which we know has no effect on the bacteria. That will tell us how many bacteria will be alive if we don't kill any of them. If the new drug is working as we'd like, there should be fewer cells left alive in the first tube compared to the last tube, and ideally, the number of cells still alive, if any, should be the same in the first and second tube. So controls are important to scientists because it helps us validate the performance of our experimental setup, and it tells us what effects we can reasonably expect to observe. That gives us context for our experimental results.